Okay, so remember I told you about this controversy between Leibniz and Newton? Well, it's because of the different notations that they had. And as it turned out, the notation that Leibniz used was much easier, and it's what we primarily use. So there's lots of notations for the derivative. Here's the one that Leibniz introduced to us. If y is equal to f at x, we write dy by dx, the derivative of y with respect to x. We're looking for the change in y, delta y, over delta x. Should make you think of a slope. y2 minus y1 over x2 minus x1. What does that give us? F prime at x. Okay, and we're going to find this quotient definition really useful. A slight variation occurs when we think of the process of finding the derivative of a function as an operation called differentiation. So when you take a derivative, you're doing an operation, like a square root. It's another kind of a function. So the derivative of y with respect to x, well, what is y? Y is a function of x. So we could also be saying the derivative of f at x with respect to x. So if f at x is x squared, then these all mean the same thing. F prime at x is 2x. We just found that earlier. dy by dx is 2x. The derivative of x squared with respect to x is 2x. They all mean the same thing. If we want to indicate the value at a specific number a, then this is the notation that we use, and this really can simplify your work. The derivative of y with respect to x, you draw a line and say x equals a, and then you put that a value in. Or dy by dx, x, well, what's the difference? Oh, the way they did the line. There's no big difference there. Okay, you also might use this symbol, capital D, or d sub x, because we're going to find that you can actually take the derivative with respect to y, or if you were working in 3 dimensions with respect to z, and it makes a difference what you're differentiating with respect to. Okay, we call that a differentiation operator. Okay, so f prime at x. Sometimes we get real lazy and we just write that as y prime, or dy by dx, or the derivative of f at x with respect to x, or derivative of f at x, or dx y. All of those are the same thing. A function is differentiable at a if the derivative exists. Remember, the derivative is a limit. That means the left-hand limit has to equal the right-hand limit, has to equal and that limit just has to exist. It's differentiable on an open interval a, b, or all of those if it's differentiable at every number in the interval. Okay, so for us to say a function's differentiable, has to be differentiable at every number in that interval.